Hello, Legacy Sabers, Marsh here. So today we're going to expand and condense logarithmic expressions. You're going to want to have your foldable and something to write with. No calculator needed today. I know, strange, right? Our essential question today, how do I make a complex logarithmic expression more simpler or vice versa? So first thing, our properties of logarithms. Now, there exist different kinds of properties that allow us to make a complex logarithm more simpler or a simpler more complex, depending on what we need to do. First one is called the product property. The product property is log a times b. So notice right in here I have multiplication happening in that a times the b. I can make that log a plus log b. So when I have multiplication inside of a single logarithmic expression, I can make it into two separate logarithmic expressions with them being added together. Our next one is the quotient property. The quotient property is when I have a division inside of my logarithm. So I have log a divided by b. I can expand that into log a minus log b. So I can subtract the two values together to get myself a more simpler expression, for lack of a better word. And then the power property is log of a times, or a to the b power. What we are going to do to expand that part is we'll go b times log of a. So what we're actually doing is we're taking this b term right here and we're dropping it right in front of that log. That way we don't have to deal with the a having an exponent any longer. So how can we do this? Well, remember, what log answers for us is the exponent on the base. So when did we add exponents? Well, we added exponents when we were multiplying, right? So like right here, I would have gotten 2 to the 7th, right? Because I would have added the 4 and the 3. When I'm multiplying inside of a logarithm, you're adding the information. We subtracted when we had division, so I've gotten 2 to the 3rd there. And then when do we multiply? Well, we multiply when it's x squared. Right here, when we had a power to a power, and we had to go to the next power, that's when we were able to make it go further. Now, let's actually use these properties in case. So I have log base 3 of 5 times x. Now, it doesn't matter what the base is here, as long as you just got to carry it around. So I have times on the inside of this logarithm. So I'm going to expand it and I'm going to use the product property. So I'm going to change this into two logs with a plus in the middle. So I'm going to get log base 3 of 5 plus log base 3 of x. So all I did is I just made this multiplication turn into the addition. With the two things inside of the log, I put them as plus on the outside. Let's try it again. Log base 10 of 6xy. Notice this is 6 times x times y, right? So there's three things inside of this log that now need to be separated, which means we're actually going to get 3 logs at the end here when I'm expanding. So we're going to get log base 10 of 6 plus log base 10 of x plus log base 10 of y. For every single thing inside of this log expression, I have to have a new logarithm showing up when I do my expansions. Same thing with ln. ln is just a log. Don't worry about it. It's the same idea. It just doesn't have a base. So I have two things in here. So I have ln of 7 plus ln of w. Okay? Let's try condensing now. I have addition, so that means that this is going to become multiplication inside of a singular log. When you are condensing, you should go down to a single log. If you are expanding, you should gain more than that. So I'm going to do multiplication. So I'm going to say, whoop, whoa, whoa, whoa. Sorry, guys, moved around. So I'm going to go log base 3 of 2 times 11 times 7. So I'm just multiplying the insides of these logs here. So I'm going to get log base 3 of, whatever that is, 22 times 7, 88 for a final answer there. And then I also would like to check, make sure that this doesn't simplify, like maybe it's like log base 3 of, I don't know, 27 or something. Then I could make it become just 3. So always check the final answer and make sure it doesn't simplify further. Same thing with here. I'm going to do my ln. So I have ln of, and I'm going to combine all these 3 ln's inside of one another. So it'll be 5 times x times 3, which would give me ln of 15x for a final answer there. So when I condense, I should go down to a single logarithm. When I expand, I should be expanding for however many values or terms I have inside of my logarithm. Now, let's try the quotient property. Now, remember, quotient property states to us that we subtract things that are being divided inside of the logarithm. So I have log base 3 of 6 divided by x. So this division bar right here is just going to become a subtraction sign with 2 different logs. So I'm going to get log base 3 of 6 minus log base 3 of x. So I just subtracted the 2 values inside of the logarithm and just made a subtraction. I know you're like, Marsh, this doesn't feel very mathy. I know it feels odd, but it actually is just a bunch of properties that really do help us as we continue our solving career. I have ln of y divided by 7. So again, I have division inside of a logarithm. So I'm going to change that into 2 different ln's with a subtraction in the middle, just like so fashioned. Let's try condensing. Now notice I have subtraction in between 2 logs that have the same base. That's the other thing we got to check for. So I'm going to just turn this into division. So I'm going to say log of 2 divided by 8 because those are 2 values inside the log. And I can simplify that. So log of 1/4. I have log base 4 of 3 minus log base 4 of 8. Same values there. So I'm going to say log base 4 of 3 divided by 8. And that doesn't simplify. So that's my final answer. Again, here I have subtraction, so I'm going to condense. I'm going to put the first value on top, second value on the bottom. So I have 10x divided by 2. I can simplify that, though, into just good old Mr. 5x. Now let's try the power property. Now, there is a couple of different ways to go about this one. So see how this squared is sitting outside? Now, power property, we said we just move it into the front of the log. Okay, you technically could change this into 2 different problems, and we're going to do this problem twice to show the different way. So first thing I could do is just take that 2 and drop it out in the front, right? So then it would be like this, 2 log base 4 of a, b. Well, I have multiplication inside, right? It's a times b. So that means I have to expand this one further using my product property. So I'm going to say log base 4 of a plus log base 4 of b. Now I could take that 2 and I could sit it in front of both things because I could just like distribute it basically. So that would be one way I could solve that problem. The other way I could solve that problem is I could say, well, what if I just give that 2 to both things? So then that would look something like this. I'm just going to kind of show what that would look like. So I would have done that, right? Well, then you'd be like, well, there's multiplication inside of a log, right, Marsh? So we got to change that and product property that. So I'll be like, yep. So log base 4 of a squared plus log base 4 of b squared. And then this 2, they would go sit in front using the product property. And I would get the same answer that we got. Oop, forgot the 2 there. On the other one. So it depends on how you see the problem. Both versions are correct. Both versions are the same, but you might get around it a little differently. Let's take a look. Log base 5 of the square root of 7 times x. Well, you know what? I'm going to just break this because I see multiplication, right? So I'm going to break it into 2 pieces. So log base 7 of the square root of or log base 5 of the square root of 7 plus log base 5 of x. Now you're probably like, well, Marsh, that's done. But why is this in the power property? Well, this 7, when we square root something, that's technically 7 to the 1/2 power, right? Remember that? That square root is to the 1/2 power. Well, now I have a power that needs to go drop out front. Just like so fashioned for a final answer. So I'm just simplifying so it's not log base 5 of 7 to the 1/2 power, making it a little easier. This one, I'm going to distribute the power, but keep in mind we could do exactly what we just did up here. I'm just going to distribute, so I'm going to say ln of 3 cubed, w cubed. That is ln of 27 w cubed. So I'm just going to expand that. ln of 27 plus ln of w cubed. And then I do have to do my power property. Just like so fashioned. Kind of different, right? It's kind of, it feels very not math, but it kind of feels math. Let's condense with the power property. So now I have to take the number that's sitting in front of a log and go and put it right in front on the exponent. So this is going to become log of 6 to the 1/3, which is the same as the cube root of 6, right? Same thing here. I'm going to take this little 5. I'm going to put it as the exponent. So now I have ln of 7x to the 5th, which means I have to give that 5 to both people on the inside if I want to. So that would be 7 to the 5th, x to the 5th. And 7 to the 5th, my goodness, that's a big number, I bet. That is ln of 16,000, oops, 807x to the 5th for a final answer there. Now, could you have left it in this answer? Yes, you could have. That is okay to leave it in that form too. It all depends on what you're trying to do with it ultimately. Let's expand using multiple properties. Now, when I am expanding, the first thing I like to do is usually distribute and clean up anything I can clean up. So this squared right here, I'm going to give to the top and to the bottom. So I'm going to go ln of square root of x squared over 9 squared, which is just ln of x over 81, right? Little bit easier there. So now I can make that ln of x minus ln of 81. Now keep in mind, a different version that you could have done is you could have taken that 2 and drop it in front. And if you would have done that, you would have gotten this, right? And then I would have had to distribute, or excuse me, expand using the subtraction. And then I would have had to distribute this 1/2, put that in the front of that first ln. And then if I would distribute the 2, I technically would be something similar to this. It's just that this 2 would then go back onto the 9 to give me that 81 that we had there. A little bit different depending on what your answer is. You kind of gotta be a little flexible to be checking your answers if you're looking at someone else's answer key, because they might do it just a tiny bit different than you. Let's try another one. So first thing I'm going to do is I'm going to treat this one, I'm going to distribute the 3 to absolutely everybody. So I'm going to get log of 6 cubed, which is 216, x cubed over, and then 11 cubed is 1331. I'm going to check that fraction. 216 divided by, I'm going to make sure that that fraction doesn't simplify. Using my fancy calculator. Oh, no, it doesn't simplify. All right. So now I'm going to take care of the division bar next, just because it's kind of almost like a parenthesis. I'm going to take care of that first, which means I got to change into subtraction, right? So I'm going to say log of 216x cubed minus log of 1331. And now I have to expand this section. So that is going to give me an addition because it's multiplication in there. Just that log of 1331 just kind of hanging around there. And finally, I have an exponent that needs to drop in front. Oops, missed my plus. Like so fashioned for my final answer. And again, different answers do exist. It all depends on how you attack the problem, depends on how you see it. But your answer and my answer should look kind of similar in the regards. You might have 3 log base 6 and minus 3 log of 11. And if that's the case, that's fine. But just keep that in mind. Let's condense. So first thing, when I'm condensing, I always make the numbers in the front go to be exponents again. So I'm going to take care of those guys, bop them back up. So this is ln of the cube root of 8 plus ln of, 8 cubed, 512 x cubed. Addition is going to turn into multiplication. So I'm going to say ln of the cube root of 8 times 512 x cubed. Does a cube root of 8 times 512 simplify? I want to say it does. Oh, of course it does. Cube root of 8, Marsh. That's 2. I was not thinking, people. So this would be 1024 x cubed. See, guys, Marsh should have been paying attention. She wasn't thinking about the cube root of 8 being an actual number there. Last example. Again, put my stuff up there. Oop, did we just do this? Nope, similar though. So I'm going to get log base 3 of 864, 8 squared, plus log base 3 of 512x cubed. And then 64 times 512. Oops, Marsh can't type on a calculator. Ooh, big number, 32,768 x cubed for a final answer there. Now, why are we doing this? Well, we're going to have equations that have more than one log, something like this. And what that's going to allow us to do is this subtraction is going to turn us into a division problem. So like this 2 would go and be an exponent, and then we would change that into division. So we would have a problem that would look like so fashioned. And from that, we can solve. So what this is allowing us to do is solve very much more complex and scary looking log equations with relative ease because we have properties that are going to help us with it. But with that, that is the end of this video. I hope you enjoyed log properties. We're going to practice them quite a bit in the next couple of days. But until then, I will see you later, Sabers.